Awesome. Well, I'm super excited to be here. I did come in just for all of you. But no, it's really delightful. I've been to Heathrow many a times, and into London, and into Edinburgh, and a few other places around town. But it's the first time in Oxford, and it's absolutely delightful. It's just like home, nice and rainy and gray and cold. So I felt just like I was in Seattle, and it was very, very nice. In fact, I really loved it. I went out immediately. Started walking around, got some coffee, got some waffles, got some more coffee later. So it was really quite nice, and it's absolutely stunning. I love coming to Europe because it's just so different than just the US, because I live in Seattle, compared to like maybe Boston, which is a little bit more European influence in it in general, but just like everything's so beautiful and people are lovely. And very warm and welcoming. So I'm really excited to be here. Like I've been doing a big tour. I came for one conference in Bulgaria, and then I put out this big call to our MVPs and the user group leaders, and I said, I want to speak as many times as I possibly can in 10 days, and I have 9 talks. So basically every single day, just talk, except for tomorrow. So I have 1 day of off, but I'll be traveling as well, so it'd be quite good. And yeah, so what I wanted to do, I was talking earlier, is I've been talking a lot to Xamarin user groups, and I was at some Xamarin specific events. So I kind of wanted to take a step back and kind of reintroduce Xamarin to the world, I would say. So maybe some of you have heard about Xamarin in the past, maybe are using it today, or maybe brand new. What I really wanted to do is tell you the story of what it means to be a .NET developer that wants to build mobile applications with Xamarin. Because what we like to say is, yes, there are web developers, there's mobile developers, there's desktop developers, but really as a .NET developer, you're all of these things. Your skill set applies to absolutely anything. So if there's one thing that you take away, besides that hopefully Xamarin's pretty cool, is that if you're a .NET developer, you can build for absolutely anything. Like you are a mobile developer, you are a web developer. And there's just frameworks that you learn. There's so much resource available on the internet, and you can do it. So I'll get started, and I'm going to break it into sort of 2 segments because we're kind of talking to take a break. So I'll probably go like half an hour, take a 15-minute break, do another half an hour. We'll go from there. So I'm James Montemagno. I'm a program manager at Microsoft, and I oversee all of our client developer tools. Specifically focus on Xamarin, but I work very close with our web, with our desktop teams, with our Azure teams, with our DevOps teams. Basically anybody that will talk to me, I will talk to them. I came from Xamarin, so at Xamarin I was a developer advocate for 3 years, and before that I was a professional mobile developer using Xamarin. So I've been in and around Xamarin for 8 years. And I've been a .NET developer ever since I found it in college back in 2006. So I've been doing .NET development for as long as I can remember, and I love every moment of it. And what's really interesting as time goes on is that software really truly is kind of driving more and more businesses. And we've always said that, like software is driving businesses, but actually today, software is businesses. I mean, if you were to take a look at like scooters sitting around, or Uber or Lyft, or just even going into Heathrow, right? Like literally, businesses are not only being transformed, there are some businesses that are only their software. And there is companies that literally built those kiosks so I can scan my passport. And yeah, it didn't work, so I had to go talk to somebody. But like somebody does that, right? I was so close. It was actually really creepy. I'm kind of glad we don't have those yet, but I know that it's coming. Everyone will be retinal scanning all the time. And this is really important because as software developers, that means that we're going to have more and more challenges too. We have the opportunity to drive software into everything that we do, but we have more and more challenges. We have more and more devices. I mean, if you were just to look at that kiosk at Heathrow where I put in my passport, there was literally a scanner inside of there. There's a screen showing me my face in real time. There's like 18 cameras pointed at me, and then there's software that is driving the gates open and closing, just in that one little box, right? Which is really impressive. As a client developer, there's not only phones that I have to worry about, but there's tablets, there's televisions, there's wearables, there's IoT devices, there's all of these different devices and emerging platforms that we're speaking to, that we're interacting with our eyes instead of touch. And of course, everything is literally being powered by data and AI and intelligence. So there's a lot for us to take on. And while it's a lot, I think it's a really exciting time to be a .NET and Microsoft developer because there are more devices, more emerging platforms, and Microsoft is on board with that too. We've of course been known for building Windows and building desktops and laptops and getting into the mixed reality spaces with HoloLens, but for the first time ever, we're actually branching outside of our own operating system. Just a few weeks ago, we announced the Surface Neo and the Surface Duo devices, which are brand new devices that are coming out next year. The Surface Neo, which is on the left, is a dual screen laptop. It has a keyboard that snaps on with magnets, which is very cool. Completely opens and does a full 360. That's running a version of Windows 10 called Windows 10X that's specifically optimized for these dual screen devices, a whole new category. And then on the right-hand side, you have the Surface Duo, which is a dual screen mobile device that's being powered by Android. So literally for the first time ever, Microsoft is going to be shipping devices that's not even running their own software. I think that's really powerful because we really want to enable every single person and organization to really achieve more. That's exactly what it says on the back of my badge. I have it memorized. But it's true, right? No matter where you're at, we want to be there with you and make the best devices and make the best software as well. So to me, this is really exciting because as a .NET developer, I can already develop for both of these devices today. There's no magic sauce that I'll need to learn. As a .NET developer, I can do it. And in fact, as a .NET developer, you can truly build for anything, whether you want to build a desktop app, web app, cloud application, mobile application. .NET is your platform to build anything. And that's the message that we've been really driving home, is that if you're a .NET developer, you can build for anything. And we, on the .NET team, and Xamarin's part of the .NET team, under our developer division, which includes Visual Studio, Xamarin, .NET, and all of the other frameworks that power us to be able to hit these targets. So you have WPF, UWP, ASP.NET, and then Xamarin, which is our mobile-specific framework. So as a .NET developer, you already have all the base skills. You have the language, you have the IDE know-how, you can build out those shared user base code bases with your models, view models, RESTful service calls, Azure integration. You already know literally 80% of targeting any of these things. It's just learning the specific framework that will enable you to create the best application for that platform. Now I'm going to focus in on mobile specifically and with Xamarin. So a lot of people ask me what is Xamarin in general. It is a very fancy name. And it's not a company. It's a company that was acquired, but the company made a framework that was also called Xamarin. When you got a good name, just keep repeating it, I guess. But it took me a while to sit down and really try to articulate this in like one sentence. When someone would come to me and say, what is Xamarin? If I'm in an elevator, I can pitch it to somebody. So I boil it down to this, which is an open source app platform from us here at Microsoft for building modern and performant iOS, Android, macOS, watchOS, and tvOS applications, all with .NET. I often only talk about iOS and Android and being able to share code with Windows or other operating systems, but Xamarin, the core framework, powers all of these different operating systems to build great apps in .NET. And best of all, everything about Xamarin is completely free and included in Visual Studio Community Edition. So there's no cost, anything like that, it's free. And there's tons of companies all over the world that are building their applications powered by Xamarin and .NET in every single vertical that you can think of. From British Airlines, which I just checked in on for my flight tomorrow, to UPS that delivers half my packages in Seattle, to of course Microsoft and all sorts of different companies around the globe. And these are just some of them in all sorts of different verticals. And we have a whole case study on our .NET website at xamarin.com/customers. So if you're actually building Xamarin apps, we would love to hear about it. And we have a little submit form on the bottom where you can submit, and we'll do blog posts, and we put all icons and everything like that on the website, which is really great. So like I said, I'm going to focus in on app development and sort of what the Xamarin team, part of Microsoft, has been trying to focus on and enable all of you to do, which is not only to enable you to build beautiful mobile applications for those operating systems, but the team really wants you to be super productive, use the environment that you want, no matter if you're on PC or you're on Mac. We want to enable you to maximize your code across all platforms. And what's really essential to Xamarin has always been is that we give you those native performance and native integrations into the operating system. There's always a reason why someone buys an iOS or an Android device. They usually like the hardware, but they also love the software. So we want to give you the ability to target that platform and optimize it and really stress it so you can finely tune and create that perfect application. And then what's great about being part of .NET is that you have this huge .NET ecosystem readily available to you. And we expand upon that with awesome mobile integrations, and I'll talk about that today. So I mentioned that we have Visual Studio. It's free, and of course we do have Visual Studio. When you install Visual Studio 2019, there's just a checkbox for Xamarin, which will include everything that you need. We've super slimmed it down. It's just a few gigs, which includes all of the Android SDK tooling, iOS tooling, anything that you need. We've reduced the install size by more than 70% from Visual Studio 2017, so it's faster than ever to get started. And of course, you get advantage of everything in Visual Studio. So if you have extensions that you're already using, like you're using ReSharper or some other feature, you have access to that. You get all the IntelliSense, code cleanup, IntelliCode, live share, pull request reviews, everything, because it's just Visual Studio. We're a workload inside of it. If you're on a Mac, we have you covered too. We have Visual Studio for Mac. It's a free IDE again that will enable you to do not only your mobile development, but Unity game development, ASP.NET Core, Azure Functions, ASP.NET Core websites, .NET Core console applications, or worker services, basically anything in the .NET ecosystem. We're constantly iterating on it. We just released a brand new version with a brand new code editor, which I'll talk about here, and huge performance boosts. And the other advantage here is that also Xamarin is completely open source, which means anyone can build tools for Xamarin, so like JetBrains does for Rider, for instance, and that's great because if that's your IDE of choice, you can do it. We think we have a pretty great IDE. It's completely free, so go there, but whatever IDE you want to use.
So I shouldn't mention Rider, should I?
No, you can do whatever you want. We love everybody. Yeah. Better use an IDE than not use it at all, right? So, yeah, we always like to say if there's a reason you don't want to use Visual Studio for Mac, let us know. We would like to fix it. And what's really great about this is our architecture. So I'll kind of open up and get into the depth of Xamarin. So when you build a Xamarin application, or really just any .NET application, you sort of have these head projects. So you have your iOS project, your Android project, and then literally any other .NET project. So that could be maybe a Mac application, a TV application, a desktop application. These are your head projects. And this is where you're going to access and create native user interface for each platform or access the native APIs. And ideally, this is pretty minimal code because what you really want to do is create a huge shared C# code base. Now, often that may just be business logic, so those models, view models, controllers, RESTful service calls, databases, things that's just .NET code. But the Xamarin team and the .NET team, we work really hard to extend the platforms to offer more cross-platform APIs. So not only accessing native platform features, but also creating shared user interface. So you kind of mix and match these together. But at the core, when you end up compiling your application, you get full native performance, access to 100% of the APIs on each platform. And what's really, really unique is that you access everything from C#. You never have to write any other language, open up any other tools if you don't want to. And that is actually the most unique part about Xamarin compared to other cross-platform tools. I think it's actually pretty unique that we allow you to build an iOS app in C#. I think that's pretty cool. Some people say it's not enough. But the most unique part is, and the real sell that I love, is that every single API in iOS and Android is available to me in C#. So I never have to write any bridge glue or like kind of go in and write Java or Objective-C or Swift and figure out, and I'm already learning multiple platforms. I don't want to learn 4 different tools, 4 different programming languages. I just want everything in C#. So how this works is like this. What we do is we say, we have .NET. And Windows developers for a long time have had .NET readily available. We have .NET Core now, and we just have beautiful, lovely namespaces available to us. So System.io, Link, XML, kind of the things that we love as .NET developers. Then if I want to create a Windows application or some other application, I'll go download an SDK, get a bunch of platform-specific APIs. Now what the Xamarin team does is we work closely with all of the .NET team, and we bring .NET to iOS. We essentially have a beautiful .NET runtime that runs natively on iOS. And that's all those gray components on the bottom. So all of your .NET code is going to run just as performant and be shareable across any of the .NET platforms. And then up top what we have is all of the iOS-specific libraries, the namespaces. This is 5 of about 100,000 probably that iOS has. And these are iOS-specific APIs, so SiriKit, UIKit, MapKit, Augmented Reality Kit, Core Machine Learning. There's tons more that are in there. And what the team does is they create these C# bindings around every single API that's inside of iOS and also Android. And they don't stop there because it's not just like a p-invoke sort of wrapper. This binding adds C# features like async await, lambdas, events, delegates, things that we sort of know and love as .NET developers. So we improve the API. We say the API for iOS, that's good, but we're going to C# and .NETify it. And we do the same thing for Android. You get all that .NET goodness on the bottom, and then you get all of the Android libraries, Google Play services, Android support libraries, everything that you need for an Android application. So you have access to all of this immediately when you install the Xamarin tooling. And then when you go to actually compile and build, we give you full native performance. And how this works is on iOS, we do a full ahead of time compilation. We take C#, compile it down into IL, compile it one more time into LLVM bytecode, just fancy word for an advanced compiler and optimizer for that bytecode that produces an ARM binary. And you just ship that ARM binary, just like any other iOS developer would, up to the Apple App Store, your own internal app store, or anywhere you want to ship that app. So you get that native byte machine code that's going to be running performantly on an iOS device. So whether it's iPhone, iPad, or any of Apple's different devices, they all go through that same chain. On Android, we also have an ahead-of-time compilation, but most of our Android applications use just-in-time compilation. Because how Android works is they already have a runtime. They have the ART runtime or the Dalvik runtime. And we're able to run our .NET runtime side by side. We run your .NET code over here, and we JNI across, which is Java indications, when we need to speak directly to Android or Java APIs. Now, to your users or to you, you don't really know. You're just writing C# code. Your user just installing an app. It's just an app. You probably have Xamarin apps on your phone, and you have no idea. And you then take that Android application, ship it to the App Store, send it to a friend, send it to testers, and you have a beautiful, fully compiled application. And that's sort of the start of how it works with Xamarin. So for the first half, I'm going to focus in on just pure traditional native development for iOS and Android. So nothing cross-platform. We'll create some shareable code. I'm going to show you that it's not crazy. You're going to know most of the stuff I'm going to talk about. And I'm just going to go in and start building an Android application. So nothing crazy cross-platform, just pure traditional stuff that I fell in love with 8 years ago. So I'm going to open up Visual Studio over here. This is Visual Studio 2019. And when you say create a project, you're going to have all sorts of options in here. So if I zoom in here, we can see that normally you have all these filters on this project. So I have a bunch of, whatever you have installed, these are specific templates. And if I say all project templates, and everything will show up in here, just so much stuff. Now when you filter down to mobile, that's where the mobile templates come in. And the first one up top is our cross-platform template, which I'm going to talk about in a little bit with Xamarin Forms. But underneath are traditional templates, Android application, iOS application, we have Android Wear, watchOS, standard class libraries. We also have tvOS application for Apple TV. And then we have all of these iOS extensions. And this is really unique because when people ask me, well, how does Xamarin stand out across from other different frameworks? I said, well, we give you the ability to do anything. And iOS applications nowadays are not actually just one application. There are a bunch of micro applications built in. If you're on an iOS device and you share an image, there's a document picker extension that an application implements. There might be an action sheet to share, things like that. And we enable you to add those onto your applications with easy templates. So Normally what I would do is just create an Android application to get started. I've created one ahead of time and scaffolded out just a little bit of code. So we'll take a look here. It's called Demo App. It's a great name for an app. It's an app that is a demo. So when you create that Android application, it usually just creates just the Android part. What I've done over here is I've created my demo app, which is a little Android app, and a .NET Standard library. This .NET Standard library is a newer project type that we created. It's a very slanted thing up here, but it's OK. I'm just going to use this thing right here. There we go. So this .NET Standard is a new project type. And what we did is we had all of the .NET platforms, all those little bubbles that you saw up there. We said, let's have a simple .NET contract. Because they each kind of run their own flavors of .NET currently, we said, let's create a contract across all of the different platforms, so mobile, web, desktop. And .NET Standard enables developers to create a single library that can be shared on any of those platforms. So what I have here in this demo app, it's an application that will list and find from the internet a bunch of monkeys. That's very important to have. It's the best application ever, because I love monkeys, and I should always have an application that shows me monkeys all the time. If you ever watch me on streams or do demos, all about monkeys all the time. So this application is pretty simple. It has an Android application up top, so we can see about that little tiny Android icon. And we'll notice that some things are similar to what a normal .NET project looks like. There's a property here. There's an assembly info with assembly information about the app. Then mixed into here is some Android-specific things. So this Android manifest XML file is sort of a description of my application when I actually put it onto an Android device, such as version code, version name. Just like a Windows application has a manifest file to describe the version where it can be allowed to run. Then inside of here, I have references. So just normal references to system, system core, NuGet packages like newtonsoft.json, and then have a bit of Android stuff in here. So I have some Android support libraries, which enable me to create beautiful material design applications that go back further on older Android devices. I have some really cool Android libraries, such as Glide, which is a fine-tuned image downloading and caching library that is a standard in the Android world. The team at Microsoft creates all of these libraries for you. You can create your own. So if you have a Java or an Objective-C library, you can create your own C# binding around it. But all of the core essential ones we do for you, and they're all open source. So just some references here. And then what we have in a normal Android application are these things called resources. So this is where any of my Android views or icons are going to live. And also in these values are going to be colors and strings and styles. That's what's going to be inside of there. And since the Xamarin application is a native application, we follow the same exact file format that an Android application has. So if you'd ever created an Android application in the past or seen one maybe in Android Studio or heaven forbid Eclipse, then you would see something very similar. You'd see like an R folder that has layouts and drawables and bitmaps and values inside of it. And this is the resources. And every Android application has all of these with specific IDs, and they're composed of Android XML markup files for the user interface. So really, since we follow the native format, we actually go through the same exact native tooling. And this is actually really important. So as Google makes advancements in their compilers, their optimizers, their linker technology, we get to take advantage of that. We go through the same exact SDK and the same exact compiler. But we add that sort of Xamarin magic because we're compiling C# code into native machine code. We're not transpiling. We're not doing anything like that. We're actually generating pure machine code because we have a full .NET runtime there to execute your .NET code. But we can go through the same builds structure for the Android-specific parts. So this application is going to display some monkeys, and I'm going to create some user interface here. But what I want to do first is just focus on this shared code. So what I've created is a monkey, which is just blank. So it's a public class. I'll make it a little bit bigger for everybody. There we go, maybe 200. Perfect. And then I have a monkey view model. So the monkey is going to be a representation of what a monkey is, my data object. And then I have a monkey view model. And this is going to be some code behind for my page that's going to list all the monkeys. So I've created an observable collection of monkeys, which will list all my monkeys. I can add them, I can remove them. And I'm going to have a single function here that's going to go get monkeys from the internet. So what I'm going to do is go and get some monkeys from the internet. So like every good developer, on their personal website, you should have a JSON file of monkey data. So it's just best practice. And you can copy this, and what's really cool is you can go into Visual Studio, and you can simply come in and do edit, paste, JSON as classes, and that will just put all that in there. And it'll do its best to say, hey, this object here, it was an array and it has this property, and you can get the names and things like that. Luckily, our JSON was really elegantly structured with proper C# names such as name, location, a string, and some latitude and longitude. But there's some tools online that are really great too. One that I like to use called QuickType. QuickType is an application that was built by some former Microsoft employees. With their goal is that JSON is everywhere, so you should be able to come in, paste it in to the inline editor here, specify the name, and then just get beautiful C# code over here. Get helper methods that will convert it from JSON to your array. Handle all of the JSON settings for you. And what's really cool is that you can actually give it namespaces. You can see if you want arrays or lists. You can share it with a code. Or you can convert it into any other language you want. Basically, they support every language under the sun, because as developers, sometimes we might have to write a little bit of JavaScript here and there, or we might have some other project types. Basically, I mean, it should all be in C#, but sometimes it's not. So it's cool to have one tool to do all of this. So what I'm going to do is I'm going to come over here and just copy this. There's a copy code button. Boop. And I'm just going to paste the entire thing in here. And what I really like about this is that it does give me all of the namespaces I need to use. And then if for some reason, like JSON usually has like lowercase names, it'll automatically add the JSON.NET properties for me. It will come down and automatically come in here and do this really nice deserialization with JSON.NET. So I give it some JSON, it handles everything for me automatically and gives me one little static method to call. So just have some C#.NET classes there. So now what I'm going to do is go into my monkeys view model. And what we're going to do is we're going to write some .NET logic to go grab those monkeys from the internet. And again, this is just in a .NET standard project, so I can share this with any .NET app. So I'm just going to go ahead and do a try catch here. And for offline or something like that, maybe I'll try catch this. I'll just do a simple debug.writeLine and output that there. Here, Visual Studio will tell me to bring in my namespace. Awesome. That's cool. Asks me if I want some Roslyn analyzers. No, it's OK. And that's probably all we'll need to do. And we'll just, never write unit tests. And it'll always pass. So it's perfect. And so here we're just going to go ahead and go get some monkey data. So what do we use? HTTP client. So we'll say var client equals new HTTP client. And what's great about this is it's the same old HTTP client that you've been using for years. So you can do posts and puts and gets and all that stuff. And automatically, when you run it on iOS or Android, we will run through the native iOS or Android stack. So it has full TLS support, SSL support, everything that you would expect. And you just use HTTP client. So I'll say var JSON equals, and I'll await. So we have full async await support. I'll say client dot. And I will say get string async. So I'm just going to get a big string from the internet. I'll put in my website, montemagno.com/monkeys.json. Perfect. There we go. Now we're going to go ahead and get those monkeys. There we go. And I'll say monkey dot and use that extension method from JSON and just pass it the JSON. So now here we have a list of monkeys, an array. And I'm just going to say for each var m in monkeys. I'm going to add it into this observable collection. An observable collection is just like a list, but whenever I add or remove an item, I'll get a property changed event. So I can subscribe to that and then update my user interface whenever anything is added or removed. So I'm going to say monkeys with a capital M dot add. There we go. And just add in the monkey there. So this is literally just C#, just .NET code, stuff that you can write today. Nothing magical about this for iOS or Android. It's just .NET code. So now what we're going to do is we're going to put it into our Android application up here. I'm going to build it really quick because I did some undos earlier. So this Android application, like I said, has a few different pages in it. We're going to focus in on just a single screen to display some monkeys. Now, it is an Android application, so it means that there's Android-y things inside of it. I showed you the Android manifest earlier, but we have these layouts, which I'll get into in a second. But every Android application, no matter how you build it, whether it's cross-platform, it's native, it's traditional with Xamarin, you'll have these activities. An activity is a screen of your application. So this activity will be the launching point, so when the application starts up. And what I've specified is that it is an application compat activity that comes from one of those Android nougats that I showed you earlier. For all intents and purposes, every Android application is an application compat activity application because Android is crazy. If you're ever curious how crazy is it, you can always just go to Google and type in Android dashboard. And then usually the very first one, distribution dashboard there, will show you all of the different versions of Android and the percentage of that version of Android that's in the wild, that's accessing actively the Google Play Store to download apps. So my wife just asked me, she said, hey, my device isn't getting updates anymore. She has an old Nexus tablet, and it's running 6.0. I think it launched with 4.4. And it's a pretty old tablet, but she's a little concerned, is it going to get updates? I said, well, don't worry. Nearly 20% of the world is still running that operating system from, let's see, 10 came out this year, so 1 year ago, 2 years ago, 3 years ago, 4 years ago. It's quite amazing, actually. So what Google has done is they've created all these compat shims, basically, because as they create new versions of Android, they can't add the new features there because nobody has it. So they give us libraries as developers to actually add those new features older. It's very interesting. It's amazing. It truly is. It's a beautiful disaster. It is also my favorite operating system, so it's a joy. So this activity is my main launching point. So we add some really cool things in .NET. We add this attribute called activity that you can put on an activity. And normally in the world of Android, you'd have to go into your manifest, you'd have to write some code and a bunch of XML. We just say, it's an attribute. We'll figure it out when you compile it. We'll generate a brand new Android manifest for you. So this is saying that there's a string inside of here called app name, which if I go into my strings, there's my app name called demo app. And it's also saying that there's a theme, which here is this app theme that I've specified over here. Android applications are a bunch of themes. So this is an app compat theme, so I get beautiful material design. I specify a few colors here. So here we have some nice inline IntelliSense with colors. If I hold down Control, I can actually deep link into that color, which is inside of my application. So here I have the color, and I can see the colors that I have specified inside of this XML file. And then I have a bunch of other properties because I'm going to add my own action bar, a little toolbar up top. So we define light themes, dark themes for Android here. And then I also add on top of here that it's the main launcher. So this is the main launching point for my application. Android applications can have multiple launching points. Nearly none of them do, but you could have multiple if you were creating an internal app and you had like a receipt dashboard and you had an admin dashboard. You could have 15 icons. I don't know why you'd want to. Don't do that. That's a bad idea. But you could. And what this application does, this activity, is it has an onCreate method. And when I onCreate it, the first thing I do here is I say set content view. and this is going to find an XML file that it's going to inflate. And then I can find anything inside of it. So I find a toolbar, and I find this fragment container. So there's a part inside the screen, and I put in a monkey fragment that's going to have a list of data. Now, inside of here, I have a few other things like permission requests. I can also say override. And when I say override, this is going to give me all of the Android-specific items that an Android developer would find. So when, for instance, a window was attached, or when the user pressed the back button, or maybe when the application or the screen was restarted or resumed or paused. So activity lifecycle there I have access to. So we want to go ahead and first take a look at this monkey fragment, because that's going to be the part of my application that the user sees. I did say that an Android application is an activity, but usually an activity holds a bunch of little fragments, pieces of screens. That way it gets really high performance. So an activity is heavier, fragments are lighter weight. So normally when you navigate in an Android app, they're swapping in and out fragments. So if I go inside of here, this is inside my Android application, and this is where the magic happens. This is where I create my view model. And this is where I will start to call those methods in my application. So we're going to create a little bit of user interface here, because I have it sort of set up, ready to go, but we're going to create the UI. So I'm going to go into my layout file, and I'll give you sort of a rundown of what maybe a traditional application would look like without just a list of data, because lists are kind of generic. So let me boot up this other demo screen first that I have, which is a login page. And this login page is very simple, because I think before you kind of get into the heavy like list views and recycler views and all this Android adapter stuff, like everyone kind of has seen a login page. There's a username, there's a password field, and there's a login button. So Android applications are made of XML. And XML in Android is just kind of like XAML, but it has Android everywhere, so you know it's Android properties, and they have Android controls. So we have a full designer built in here. I can swap between my different themes and layouts. So if I wanted to see what it looked like with no action bar, with the action bar, it will preview it here. I can tap on items. I can pull up a property grid for whatever item I'm on, et cetera, and toolboxes and all the things that you would expect. Now, there's a lot of cool things that we did. We just recently updated our designer to make it super speedy, really performant with brand new tools. But we also rewrote our Android XML IntelliSense from the ground up, and it's powered by Roslyn, our C# compiler and optimizer in IntelliSense, which means it works 100% the same on Visual Studio for Mac. So there's a lot of cool things inside of here that I can do. So for instance, I showed off a little bit earlier that when I look at a color, such as background, that I can see that this is an attribute, and we show you the nested hierarchy of where this is coming from. So we give you a bigger preview of the color. This is actually being referenced by the color primary, which is actually using this hex value. Same thing for color. This is an Android resource, so this comes from Android. They predefine a bunch of things, and that's one of them. We rewrote our IntelliSense. So for instance here, instead of using login as a hard-coded value, maybe I want to translate it. So I'm going to say @string, and then I can do /login, and there's a few different logins in here. So login hint and login button, and you can see we give you the string translation right in line, which is really nice. So right there. We also have a lot of nice little tricks that we did inside of it. So let's say I just am highlighting a few parts of this edit text, and I want to comment it out. That's a little entry box. I can just comment it out, and it figures out the entire element inside of there. In fact, if I want to, I can just have the cursor there and hit uncomment, and it uncomments the whole thing. So there's little tiny things that we've done inside of here. And of course, I can see what this application looks like in portrait mode, in landscape mode, different versions of Android, different devices, all the different things inside of there. So that's kind of an overview of the designer and what this looks like. And what this page is doing is it has a linear layout, which is going to stack elements just vertically. You can do horizontal or vertically. And then I have a few elements like a text view, which will display some text, an edit text that I can edit, and then a button here that's themed. But let's go ahead and create our monkey list. So we're going to have a list of monkeys. So I'm going to open up the main monkey fragment, which I was inflating earlier. Now, this has a linear layout, which we saw earlier in the login screen. And then it has a button. It's a beautiful user interface. I created it myself. It has a beautiful button that says refresh. And when I tap on it, I'm going to call into my shared code. And then I have this thing called RecyclerView. And you can see it's an Android support v7 widget. And this is a support library from Google. A RecyclerView is a really highly optimized list view. It can do grouping. It can do horizontal, vertical. It's really beautiful. It does all sorts of things. But what we can note inside of here is that we have this RecyclerView. We're giving it a width and a height. And then we have these like tools things. And this is something brand new that we added into our designer. And it's part of Google has it in their designer too. And these tools are little designer-specific helper methods. So the first one here is it's saying list item. That list item is the cell. So how do I see each of those monkeys? And then an item count. So over here I have 1, and if I put in 3, for instance, it's going to show me 3. Now this monkey, though, is only showing me item 0, sub-item 0, and I want to display an image, so it's probably not finished. So what I'm going to do is hold down Control, and we can see that it highlights it here inside of this, so I can tap on it, and it opens up that view for me immediately. And it's blank, which doesn't seem good, so let's go and fill it in a little bit. So this view, which is going to be each cell of the monkey, has 2 linear layouts. One's horizontal, and then one is vertical. So the first one is going to stack what we can see here, horizontal, so left, right. And then these text views will be stacked up inside of this linear layout. So the problem here is I don't have any data, but our designer has sample data built right in. So what I'm going to do is go into this image view, and I can say tools, because it's for the designer specifically, and there's source and visibility. Each different element has some design time properties I can add. So I'm going to add source on here, and immediately the IntelliSense knows that it's tools, so it gives me the tools here. So I could set it to a specific color or something I wanted, but we have pre-built-in avatars. So now I get a little avatar there. Pretty cool. If I come into my text view for the name and also the city of my monkey, I'm going to say tools again, and I'll say text. And here I have full names, first names, city names, and I'm going to do the full name. Boom, I get a full name. And on this text view, I'll say tools, text, and then over here, I'm going to say cities. Looks pretty good. Right. So I'm actually able to get that design time. It's not my monkeys, obviously, but it's what my monkeys will look like. But I can see it inside my list too. So when I go back over to my fragment, there are my monkeys. It has that cell, it has that design time data in line. So as I'm working on this, I'm actually able to see data of what it's going to look like before I actually run it. Because right now, we have a button, we have design time data in our list view, but we actually need to go get those monkeys. We wrote the code for it, so let's do it. So when I go into my monkey fragment that we had earlier, I do the same thing that I did earlier with instead of inflating the main activity, I inflate that fragment, which has the button and that recycler view. We have these nice little extensions that says find this view by the specific ID. So if I went back into that front, monkey here, I have button refresh, recycler view, and those are generated for me when I save the file. And then what I can do on this refresh view, for instance, I can say refresh button, and then I have all of the native Android buttons and properties and anything in that button available to me. So I can enable it, I could disable it, I could add a clicked event, for instance, here. So I'll say click, and then I could say plus equals. And I'm going to go ahead and pass in just a little lambda, so a little click event here, which is very nice. And what we'll do is we have the shared code already, that view model. So maybe whenever I press that button, I'll say refresh button dot, and then enabled, and I'll say false. And then I'll go do something. And when I'm done, I'll re-enable the button. So that's like the minimum thing I could do. And what we're going to do is say await, and I'll say view model. And we'll see Visual Studio is getting a little upset at me because I haven't asyncified it yet, but we'll say get monkeys here. Call into that shared code. And then I'll go ahead and add an async on here. So we'll asyncify that click event automatically. So we're lighting up a native Android click with async await. Psh, awesome, cool. Right? We improve the API as much as we can. So now we've refreshed that data. We have what our item will look like. Now we need to fill in the blanks. In the world of Android, any ListView, any RecyclerView has the concept of an adapter. And an adapter basically says, when I'm at this position, how should I fill in the data? What view should I use? So there's a bunch of them built in to Android. So we have a monkey adapter that I've created. And we tell it to just display it in a linear layout. So just stack them here. And you can have all sorts of crazy layouts. And this monkey adapter is one that I created. It was very, very easy. When I went into my application, I said add new file. And under Android here, we have a bunch of Android-specific helpers like activities, fragments, and we have a RecyclerView adapter. So we scaffold it out for you, just fill in the blanks. So what I've done inside of this adapter is we have a click event. We have a constructor that takes in my view model and my activity. And then whenever that collection changes, so whenever I add or remove monkeys, I added a little event here called monkey collection changed. So whenever it does, I'm going to tell my adapter to update. Say, hey, there's new data, go ahead and refresh. And then when it says refresh, it's going to inflate a view. So this was all code that was generated for me. All I did was add monkey item. So I just told it what to inflate. And there's a monkey item here. We'll take that item with the image and the two pieces of text. It will inflate it, and it will go ahead and create this thing called a monkey view holder. What's great about this pattern, while it is kind of complex, this will automatically have caching built in. So as I'm scrolling, it's butter smooth. So every view holder, I only have to find each element once ever. So here, I go ahead and find the text view, the image view down here, and then I'm able to reuse that over and over again. So once I've found it, once I've created it, I have these little bind methods. And this is when, as I'm scrolling, it says at position 0, how do you want me to fill in the data? So since I know the position, I can grab the monkey. I can go ahead and then get the view holder. It automatically had been created ahead of time. It's here. And then I can fill in some items. So there's 3 pieces of data that I'm going to fill in here. The first one is the holder text view name .text, and I'm going to set it equal to my monkey name, and then also the location. And then here, I'm going to use that very specific library for Android. So this is a normal native, actually third-party library called Glide that's going to load the image. And what this is going to take is it's going to tell it to load inside of my image view, and it needs a URL. And unfortunately, I just have a system.net URI, so I'm going to go ahead and give it the original string that I actually can just give it, and it'll automatically figure it out for me right inside of there. And that's it. The only other thing I need to do is tell it how many items there are. So I use a nice little Lambda event here, property that says view model monkeys count. And that's it. So it's a little bit more complex because it is an actual Android application, but all in all, to set this up, there's maybe about 100 lines of code that were generated for me automatically. I just filled in the blanks of what I wanted it to find. And then in my list view, I just have like a little bit of code to create it. It's pretty minimal, and I have access to all of that native UI. So now what I can do is come up into Visual Studio up here, and it lists all of my Android emulators or devices. So automatically we use the same tooling, the same build chain. So if I plug in my Android device, it'll automatically pick it up. I have an Android emulator that I started up earlier right here on my Surface Book. This is being run on top of Hyper-V. So if you're doing Docker development, you can run them side by side. We work closely with the Google team and the Hyper-V team at Microsoft and the Google emulator team at Google to run the official emulator side by side. So it's actually coming a long way, and we're constantly updating it with new versions of Windows. So I just hit debug right there. And what I'm going to do is just come into Visual Studio and let's add a few breakpoints. So I'm going to add some over here when I go and get the data from the internet and go through it. And then what I'll do is I'll also add a breakpoint when I click, right? So when I click inside of here. So what this is doing is it's compiling my application. It's making sure that my Android emulator has all of the development stuff that I need installed on it. And it's going through a full compilation right on my Windows machine. Nothing else required. It has all the build tools that were installed with Visual Studio. So now we'll go ahead and start a full debug session right on my Android emulator. And again, if you had an Android device plugged in, it would put it right on your Android device. And it would install anything that you need right there. So here's my beautiful user interface. I'm going to hit the refresh button. Boom. And I hit a breakpoint. I hit a breakpoint inside of an Android click handler that's inside of C# again, which is pretty awesome. I can debug immediately into those buttons, into those properties that I have, so I can see like what's going on inside my code. And we can see that this button is actually an Android support v7 widget app compat button. And like that's the actual native Android control that's being generated there for me, so I can see it. I can go ahead and continue on, and we'll create our new HTTP client. This will go out now to the internet, and it's going to go find the monkeys. We see our button disabled there. So it automatically is doing async await. My UI automatically updates for me. I get that JSON back. Boom, right there. There's my JSON that you saw from the internet. Here I'm going to deserialize that monkey data. Here we go. And now we have 13 monkeys in our list. All that data came right in here with the system URI, everything like that. I'll go ahead and remove this breakpoint. It'll go ahead and add it to the list. And boom, we have monkeys on a page that were downloaded from the internet with standard .NET goodness that we know already. I just added some Android goodness inside of there. And automatically I have all the monkeys, everything that I would want. So if I add items, remove items, it'll update automatically. If I add more items to the list, it's good to go. Now what's great on top of this is I can start to extend it with more shared code. Maybe I have a details page, so I have a detailed view model. Maybe I have a Azure backend where I'm downloading it. Maybe I have a SQLite database. All of that would be shared, right? And then I could take it and I could build out an iOS user interface or a Windows user interface, or take that code and share it with my web application, for instance, because all that code is shareable. And all that tooling is built right into Visual Studio to enable me to do that. And we're working with our developers and our customers every day to keep building this tooling and make it better and better and better. And it's really just that easy to go in, file new, play around with it, hit debug, and get going. It's nothing crazy, hopefully too much. And hopefully this code maybe looks like code that you've written for a long, long time. Now, if you are new to C# and .NET, well, welcome. It's the best programming language on earth. And you can go and learn all of this on our .NET website, and we have getting starting tutorials of C# and how to do all this goodness. And that's the core traditional Xamarin that I really fell in love with, just coming in, building and accessing everything. While it's not like the most gorgeous application under the sun, because I made it for demo purposes, you can really have access to every single native widget. And that's really what I wanted to show. Because inside of this fragment, right, I'm using native Android buttons, native recycler views. So if there's something that a Java developer or Kotlin developer could do, you can do it inside of Visual Studio. Same thing for iOS. If a native Objective-C developer could do it, you can do it too. And that's really just the starting point, because that is our traditional development. And I think it's really important to start there and learn there, because everything you do cross-platform is built on top of that. So we're going to take a break, and what we're going to do next is talk about cross-platform. Not only how you can access cross-platform APIs, but also cross-platform user interface, and some awesome tools that we're shipping right now to let you rapidly iterate on that. So what I opened up with, right, was just this core traditional mobile development with .NET, right? So I just built an Android application. There was nothing cross-platform yet, except for there was a big bulk of logic that could be cross-platform. So I built my Android application. I could build an iOS application. And this traditional way of mobile development, I'm building that UI multiple times. So that was that traditional architecture that I was talking about. So here, I had built my Android app, but I had that monkey view model. So now if I wanted to build a WPF app, UWP application, or a Mac application, I could do that and build the UIs again. Now, when we talk about building applications with .NET, the core of it is that we can always share our business logic. But the Xamarin team also has been very, very focused on enabling developers to create cross-platform applications. And what I mean by cross-platform is going beyond sharing business logic. And what we see in the bottom layer of this application architecture is the ability to not only share business logic, but also access to platform APIs and native user interface. So I want to first start with native user interface and then go into the UI last, because they all build on top of each other. The beautiful part of Xamarin is that you always have access to all of those native APIs, like I kept mentioning over and over and over again, of iOS and Android. So if you need access to machine learning, to face unlock, or thumbprint unlock, or permissions, or battery information, or notifications, you have access to that, always in C#. Now, the core issue here is that iOS, Android, and Windows are fundamentally different. There's 3 different companies that build those APIs. So it's great that we have access to those in C#. So if I am building the world's next best running application that I'm going to track my users like Strava all over the place, I can tap into those amazing native geolocation APIs. But I'm going to have to do it 3 times on 3 different platforms, or how many platforms I want to target. So the Xamarin team, we all sat down together and we said, we love that we have access to these APIs, and we know that our developers do, but they would sure love to have a single API to access all or as many of these native features as we can. So the team came together and we created a brand new library that abstracts over 60 native APIs into a single cross-platform library that's called Xamarin Essentials. This is my baby. I'm very, very proud of it. I was the program manager of it. I worked with some amazing engineers to build this library. And this library delivers all of those native features that are core or essential to applications. We're real original with the name. It's essential. These things are essential to every app. So things like accessing secure settings to put things into the keychain, preferences, sensors like gyroscope or accelerometer, email, geolocation, geocoding, share sheets, file system connectivity, text-to-speech, all sorts of different ones. These are only just some of them. We even add like unit converters and color helpers and all sorts of amazing core fundamental pieces inside of Xamarin Essentials to help you build applications faster. So what I'm going to do is just add Xamarin Essentials to my Android app, but in my shared code to check internet. That's what I'm going to do. That existing application, we're going to extend it because Xamarin Essentials can work in any Xamarin application. Xamarin Essentials actually goes beyond Xamarin iOS and Android. It works with iOS, Android, tvOS, watchOS, and UWP. And additionally, we worked with the Samsung team who has an operating system called Tizen, which runs on like refrigerators and toasters and phones and watches. So you can run .NET code on your toaster, and it's amazing. I actually don't know if it's on a toaster. I just assume because why not? But I believe it is on fridges, which is pretty amazing, and TVs, Samsung TVs. And you can run Xamarin Essentials on it. So what I'm going to do is just first use it in my normal Xamarin Android application. So I'm going to come back over here, and when you create any new project with Xamarin, whether it's cross-platform or just an iOS or Android application, we are going to give you Xamarin Essentials built right in. It is the core fundamental piece of every single application. We believe so, we put it in the templates. Now, that may seem scary because you're like, wow, there's all of these features. It's going to make my app really big. Well, don't worry, because what we do inside of Xamarin is when we compile an application, we apply this linker technology. And we apply this linker technology to .NET and any of the libraries that you're using. So that's why your applications aren't big with Xamarin. They're actually native size because we shake or remove or link away any of the .NET code that you don't use. And we apply the same technology to Xamarin Essentials and other libraries. So if you only use one API, that is the only code that will be included into your app. So it only adds the code that's absolutely needed that you would have had to write yourself. So when I do this, automatically in my templates, it will add a few lines of code to initialize it. So here's a little Xamarin Essentials initialization. And then down over here, I have my permissions. And it's actually only on Android. There's nothing else that I need. And if you already have an existing application, you just install the NuGet. And in fact, when you go over to docs.microsoft.com and you tap on Xamarin, boom, you're going to see all of our beautiful getting started docs. So iOS, Android, cross-platform over here. And you'll also see Xamarin Essentials. And this has all of our feature guides for every single API, the ones that I was showing you up there, and more right inside of here. So if you're interested in connectivity, for instance, I can tap on it. And that's what we're going to add. Over here, it's going to tell me, oh, this needs permissions, right? So we don't add all the permissions for you, because then your application would have all the permissions, and then your users would be like, hey, like, why do you need 5 billion permissions? I mean, you're not using any of those APIs. So you add them to your app, and we show you how to do that. iOS and Windows don't need anything. And then down here, we literally just walk you through how to use it. Using statement, checking the network active access, what the enum that return means. If you want to check if it's on Wi-Fi or LTE, or if you even want to register for network change events, we have that built right in. We even walk through any sort of limitations. Like for instance, on Android, it's impossible for us to tell if you're behind one of those API gateways. Like when you go to a hotel or a Starbucks and you have to like click a button, you're actually connected to the internet, but not actually connected to the internet. So in this instance, there's no API in Android to determine that. So we'll tell you the best that we possibly can. What I love down here is that we have videos for nearly all of these, which is really cool. But more importantly, we have source code and API docs right here, because Xamarin Essentials is fully open source. So I can go to the API documentation, which is the exact same documentation that you'll see inside of Visual Studio. But you can also go into GitHub, and you can look at all of the source code. We build it all completely in the open. So if you're really, really, really interested in how it works on Android, you can browse through the hundreds of lines of code that we've written for you, so you don't have to write it. So let's implement a little code in here to check internet. The first thing that I've done is I did follow that documentation, and I went ahead and added that permission right here into my manifest. So I say uses permission, and it'll automatically generate the Android code needed for that. Now I'm going to add it into my shared code, because I may take this shared code and put it in an iOS app or a Windows application, and Xamarin Essentials allows me to access code there on any platform. So what we're going to do up top is we're going to say if, and I can say Xamarin dot, let me zoom in, boom, essentials dot. And now I have every single API available to me. So accelerometer, battery, all this stuff, right? Browser, clipboard, compass, connectivity, all this stuff. So here's connectivity. And then what I'll do is I'll just simply shorten up the namespace. So connectivity, bring in using Xamarin Essentials. And now immediately I have access to connection profiles. I could register for changes, or here, we're going to check for network access, right? And then I'll say if it doesn't equal, and if it returns internet. So here we have constrained internet, internet, local internet, none, for instance. So it's going to say if I don't have internet, then I'm offline. So what I'll do here is I'll simply say debug.writeLine. And here, IntelliCode is actually popping up in place here. IntelliCode is a feature of Visual Studio 2019, where we run machine learning on thousands upon thousands of open source projects to predict the code that you're going to write. You're going to see that a lot more coming up, which is really cool. So I'll say no internet, right there, boom. And I'll just hit return. Boop. Cool. So now, with that single code change, we're going to go ahead and redeploy that onto our Android device. One line of code to check internet connectivity. And as that is compiling, I want to point out that the code that's being run is the native Android code. So when I call into network access, this is the code that gets called. We automatically make sure you have the correct permission. We have to check what version of Android you're on and call the specific Android version APIs, because every version they deprecate different APIs, so you need to update it. We handle all of that for you. We check if things are available, if you have internet access. Look at that try catch where you do absolutely don't worry. That's what it says. I wrote that code. That's great. There's a possibility, so just don't do anything. And there actually is. And then we handle all of this for you. So we write all this code and can automatically detect stuff for you. So here's our application, all right? And we're debugging it. So I'm just going to hit refresh, and we'll remove some of these breakpoints that are doing stuff in here. But here I can check my internet access, and we see immediately as I hover over, internet in the far right over there. Right? Just went and checked it. If I pop over, boom, good to go. I'm going to go get those monkeys from the internet. Internet monkeys, boom. So now I'm on an emulator, so I'm just going to pop this down right over here, put it in airplane mode, boom, 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 hit refresh again, hover over network access, and we'll note right here that as I pop over it, Control plus, none. So I don't have any internet. It knows immediately. If I go ahead over, we're going to see that it's going to say debug right line, boom. My internet doesn't crash. Everything's awesome. Everything's spectacular. If I come back over now and turn back off airplane mode and then hit refresh again, we're going to see that now I have internet again. It's just that fast. It's automatically going to run that code, execute everything, and I'm good to go. I could register for changes on it, and then of course I'm going to have like even more monkeys in my list because it's just going to repeat, and I'm going to get monkeys over and over and over again as I add more items to that list and continue to work. And we do this for all of the APIs inside of iOS and Android, as many as we can. Right now we have about 60 cross-platform features that are packed in there. So if you look over on the left-hand side, you'll see all the ones that I put, but we even have more, such as like detecting device shaking, flashlight, email with attachments, orientation sensors, secure storage, like I mentioned earlier, SMS. One of my favorites is unit converters. I was basically tired of writing code to do like Fahrenheit to Celsius, so like we just do it for you automatically. What we also analyze is a bunch of the sensors inside of it. So certain things are returning hertz or degrees, and developers need to convert those. So why write that code over and over and over again? That's silly, or have to look it up on Stack Overflow. We just did it for you, which is really cool. In all of our release notes, everything is inside of here, and everything's open source. If there's a feature you want, it's either probably in the works, or you can go ahead and add a feature request in there, or submit the PR. We accept PRs all the time. Super cool. So now that we've been building this application out, we have things going, when you start to use these cross-platform APIs, your application starts to shift a little bit. Your application normally looks like this with the shared C#, but we have some Xamarin Essentials inside of there. You start to mix and match as much or as little as you want. Maybe Xamarin Essentials is perfect with the exact API for you for some of your APIs. Maybe you need something more advanced, more in-depth. You could take that code that's already been written, extend it, or just go into the native platform, check out those documentation that they have already, and you'll be good to go. So again, it's a blending of the world. It's what's right for your application. Now let's talk about the last bit in here, which is user interface. We had someone ask me earlier, like, what if I want to take and build, and share code with WPF or UWP Windows applications? So far today, I could do that, right? I could build that monkey view model, add in Xamarin Essentials, I'd be good to go. But I'd be building my UI multiple times. So just like Xamarin Essentials abstracts common common APIs into a single library, we created another cross-platform library to abstract common UI control and patterns into a single native API for you, and we call that Xamarin Forms. And Xamarin Forms is an open source mobile UI framework that lives on top of Xamarin Traditional that enables you to build these iOS, Android, and Windows applications from a single shared code base. So a single user interface layer. And how this works is through an abstraction. So if you were to go build your iOS or Android application and lay down controls, you'd have native controls, such as a UI activity indicator for that little spinner and a progress bar on Android. So instead of having to do that twice, we abstract that into a single API with common properties and events, and we call that an activity indicator. We do it again for other controls such as sliders and seek bars, and you get a slider. So we have over 50 plus controls that are built into Xamarin itself that we do like for all of this. We also have pages and layouts, so you can do stack layouts and relative layouts and grids, and you can position all of your different controls down on the page. And of course, we also work with amazing control vendors like Telerik and Syncfusion and DevExpress, and they have suites of hundreds of controls that you can take access to cross-platform. So now your applications look a little bit like this, where you have always business logic that you can share with any .NET application. Xamarin Essentials, where you can share with your desktop and mobile apps, and then Xamarin Forms, where you can mix and match in your user interface code for iOS, Android, and Windows. What's really cool is that you can even add Xamarin Forms pages to existing Xamarin traditional applications. So if I wanted to take that monkey app that we saw earlier, that was just an Android application, had no cross-platform anything, and I wanted to start to add shared pages, I can add a Xamarin Forms page into a native page because every part of Xamarin is native, which is really delightful. So what's included, like I said, are these pages, layouts, and controls that we build right into the box. But since we build it, we can extend it with awesome features. We build our user interfaces with either C# or XAML, which is an XML markup. And it's one of my favorite ways of building it because I come from a long history of XAML with Silverlight and WPF and UWP and Windows Phone, all the things. And this gives you a nice markup that also adds really cool data binding to it. And data binding allows you to have your code be linked directly to your user interface. So as I maybe type into a box, it automatically updates the code behind, or vice versa. I update that list of monkeys, the UI automatically updates for me. We've also abstracted other things, such as navigation, cross-platform, a visual state manager, so you can tell your UI to do something different when it's in landscape versus portrait, or if it's on phone versus on tablet. We have an animation API, but that is actually a native animation API. So when you tell it to fade or to translate left or right, it calls the native animation frameworks on each platform. We also included a few other services that are essential for mobile applications, such as dependency services and messaging center. So it has a full MVVM, data binding, navigation, dependency service, sort of everything that you need as a full UI framework for developers. So what we're going to do is we're going to build the same exact application with Xamarin Forms. So here's what we're going to do. We're going to close our demo application because we're done. We're going to stop debugging. And I'm going to open up another application. And all of this code is on my GitHub. So it's just my name, James Montemagno. Just search for monkey and you'll see like 20 applications, but they're there. So this monkey application is called actually App Pretty Monkey Finder. It's a pretty app that's a monkey finder application. And it's going to display a list of monkeys, but it's also going to use some Xamarin Essentials code to use geolocation to find the closest monkey to me. So I'm going to go ahead first and close everything and walk you through what this application has. So I'm going to go ahead and open this up over here. And we're going to notice that there's 3 project types. There's an Android app. There's now an iOS application. And there's still also a .NET Standard library. And this .NET Standard library has all of my models, my view models, and since I'm going to only share this code with my mobile apps, I've also put in my user interface code. What some developers like to do is put their UI in a separate library, so that way their code and their UI are completely separate. It's a demo app, so I just shove it all in one thing. So that's a nice way of abstracting it, because you can add as many of these libraries as you want. Now, I could optionally also add in a UWP project for a Windows desktop application. That's one of our officially supported platforms. Also, we work closely with the Samsung team. You can create a Tizen application. And since Xamarin Forms is open source, the community has really backed Xamarin Forms, just like they have Xamarin and Xamarin Essentials, and brought Xamarin Forms to more places. So while it's not a Microsoft official platform, you can actually bring your Xamarin Forms user interface to Mac OS, to the web, to Linux, and also to WinForms or even WPF. So if you need to, you can go there too. Officially, we do iOS, Android, and Windows and work with the Samsung team. So I still have my Android app. I still have my main activity. Boom. It looks nearly identical. I have some, some resources in here. I have my Xamarin Essentials code that we saw earlier, but I'm doing two things. I'm initializing Xamarin Forms, and I also added another Xamarin Forms package called Xamarin Forms Material Design. So I can apply material design across iOS, Android projects if I desire to do so. And how I added that was very simple. I have all of my normal Android stuff right here, Xamarin Essentials and Xamarin Forms. It's just a NuGet package that you add to your application. And what that allows me to do is instead of inflating a user interface that I have inside my project and having to build the UI multiple times, I say load application, which is a special method on my activity, which is now a Xamarin Forms app compat activity. So we extend the native toolkit. And what that app is inside of my shared code. So an app is two files. It's a XAML file and a code behind file. And the XAML file are shared resources that can be shared between my iOS and my Android project or any other head project. And I have some shared colors here that are in XML. And then I also have styles. So I created this very fancy button outline, for instance. And then I also have some code behind. And this is going to be an abstraction of what an application is. So it has a constructor that initializes a new page. It news it up right there for me as a navigation page so I can navigate around. And it even has on start, on sleep, on resume, and it's an abstraction over an app, which is really cool. What I have inside this project is the things that we saw before. It's literally the same exact code. Here's my monkey. It's the same exact code that we saw before, nothing crazy special. I have a monkey's view model right here. Now this is nearly identical. I have my HTTP client up here. I have my observable collection. But I have these things called commands. I have a get monkeys command and a get closest command. And what a command is, it's a way to link a method to my user interface. So when the user clicks on a button, since I'll be using data binding, I can data bind it to get monkeys command, and it will automatically call a method that I have associated with it. So here inside my constructor, I initialize my monkeys, my title, and then here I'm going to say the command is a new command, and when someone executes it, call get monkeys command. I have another one that does get closest command and calls get closest async. And the get monkeys async command right here does the same exact stuff. The only difference is that we have this is busy inside of here, so I don't click on that button 1,000 times, and I can enable or disable things automatically. So that's super duper nice. That's really just about it. So it's the same exact code, nothing different. So what I'm going to do is I'm going to go ahead and just hit debug on this application, and we're going to start to build out the user interface, because so far the logic is the same. I added in some of these like special command type things for data binding that I'll talk about in a bit, but we want to build our user interface. And I mentioned earlier that inside of this application, this shared project right here, are some views. So there's XAML views, so they're just like XML, but they have different elements and different properties. And if I look at this application, which is now debugging, it's beautiful and it's just a blank application, which is awesome. So if I go into my main page, which is what's been created, there's not much in here. So far, I have these namespaces up top, so this allows me to access different controls or namespaces or view models or code behind inside of here. It's kind of like a using statement in XML. And then down here I have this sort of design time. And this design time allows me to sort of help the IntelliSense. We also have a previewer built in, so it allows me to specify design time data. And what I'm doing is I'm saying there's a view model somewhere. Just go ahead and initialize it and use that for the IntelliSense. So far in this app, it's pretty blank. All I have is a grid. And this grid has 2 rows and 2 columns. I love grids because they're very easy to understand. There's rows and columns, and you can specify how big or how small they are. So I give it 2 rows, and we give it this special syntax of star. And what star does, it says fill as much of the screen as humanly possible, and that's what the first row will do. And then I have row 1, so this is row 0, this is row 1, and it's auto. So it's like make it as big as the element inside of it. So if it's a tiny little image, only make it that big, make the one above it filled. So we're going to put a list up top, and then we're going to put a button at the bottom. And then I have 2 rows, or 2 columns, sorry, and they both have star, which means equally fill the space, so 50-50. That's what that's going to do. So let's add a button in here. So I'm going to just say button inside of here. And this is a Xamarin Forms button, okay? So here's xamarin.forms.button. And when I lay down this button, it will create a native Android button for me automatically. So when I come in and I hit this, we'll see these stars, just like we saw in our source code earlier, and that's IntelliCode. So we added IntelliCode for Xamarin Forms as well. So this will automatically sort of start to fill in predictively what I should be doing in my app. So I'll say find monkeys. There we go. And then down here, command or clicked. And I'll say binding, which is that special markup that allows me to make that connection to my code behind. And since I specified that little view model up top, it knows about it. So I can say get monkeys command. And I'll just go ahead and close it out. So now, what's unique about Xamarin Forms, since we built it and we control it, we have special tooling built into Visual Studio that's called XAML Hot Reload. I'm debugging my app, and what I'm going to do is hit Control-S. I'm going to save the file. And when I do that, it's going to communicate over into my emulator and update the UI automatically with a huge button because it is in row 0, column 0. So let's go ahead and put that in grid.row 1. So that'll put it at the bottom. I hit save. It's going to take those changes and put it over there. Awesome. I can go ahead and add another button here if I wanted to. And I could put this in grid.column1. And I'll find this. I'll do get closest. There we go, and I'll say get closest command, hit save. Now, boom, get closest, good to go. But I was also using some styles over here, so it's a very fancy looking button called button outline. So I'm going to go ahead and use that over here. So I'm going to say style, and then I'll say static resource, because that's a static resource that's global. Our IntelliSense finds it, it knows how to find it automatically. I can say button outline, and I'll hit save. Now I do that, I get sort of the button is looking a little bit better here, but we need to give it some spacing. So I'm going to say margin and give it some spacing inside of here. We'll just space it at 8, for instance. Look a little bit better so it's not tucked in that corner. And I'm just going to copy some of this code and just say, hey, you know what, that thing needs a margin of 8. And now get closest is looking a lot better too. Now what I like about this though is that not only can I just hit save, but our XAML Hot Reload is smart enough to even know when I have typos. So for instance, if I was to say background color and I said orange, because some designer told me I need to make that button orange, which would be a terrible idea, don't make it orange, and then I accidentally spelled it wrong over here and I hit save, when we go ahead and save that and push it over, we're going to get a squiggly here that says, hey, argular is not a color, so you need to fix it. But I could be continuing coding on, and maybe I want this thing to be red over here. And now it's going to skip that background color of orange and still apply my red. It's smart enough to continue on, which is really cool. But let's get those monkeys in there, okay? So what we're going to do now that I have my buttons back, we're going to go ahead and add a list view in here. So we're going to add a list view up top, and I'm going to add an item source right here. And an item source is the items, so that observable collection of monkeys that are there. And what we're going to do is just open and close it, and I'm going to hit save. Now that will be at 0, 0, so we're not going to see anything yet. And the beautiful part of this is that I can actually now hit find monkeys, this will go out to the internet, and it will go ahead and find my monkeys. Now, I haven't described how the monkeys look yet, so it's just toStringing it, but there's a few things that I don't like. The first thing that I don't like is that when I click this button, I get no visual indication. So let's put a little activity indicator in here. Activity indicator, and I'll say grid.row, let's see, row span 2, grid.column span 2, and I'll put this little spinner in the center. So I'll say horizontal options center and vertical options center. And then I can say like is running. So here, for instance, I could just say, just make it run so you can see it on the page just to help debugging, and there it is, right? But maybe I only want it to be running when it is busy, for instance. And I set that in that code behind right here. Whenever I click on that button, is busy is there. So here, it's going to actually know if is busy or true is not. And it knows that because I set that binding context right here in the code behind. The one in the XAML is just a design time view, but this is the actual data binding. So that way it doesn't get reloaded every time. So when I saved, my monkey stayed there, which is really cool. So now, whenever I click on this get monkeys, we see it for a split second. It was very fast and gone. I should have put a delay in there. But I can say it is running, and I'm also going to say is visible, and I'm going to put a binding here to is busy as well. So only show it and only make it running when is busy is true. And now we're going to get like tons of monkeys in here, but we need to make them look pretty, so let's do that. The first thing I'm going to do is I'm going to say grid.column span, and we're going to span it 2 columns. Boom. Now we see the full monkeys in there. Now, just like we had in Android the adapter, the Xamarin Forms ListView has a template or its own adapter of sorts to describe what each item in that cell should look like. So when I come in, literally IntelliCode over here is just going to just write the code for me. It says I need a item template. Cool. Let me see if I can spell it correct. There we go. Now I'm also going to need a data template because I'm going to have some data binding in there. And again, it literally writes itself. Now it almost writes itself because there are some built-in things such as text cell and a view cell, but I'm going to actually use an image cell. And that's what's built in. We have these predefined ones, so you can kind of like see it really quick. But it does know that I probably want to set text. And what I'm going to do is this is going to be each of those monkeys. So the text here, I'm going to do a binding to name, which is cool. It finds that name inside of there, inside the monkey. And then we have detail over here. And I'm going to say binding to location. Cool. And then I'm going to say image source. And this image source can be an image inside my application. It could be an image on the internet. It could be an embedded resource. And in this case, it's just a string. It's an image on the internet that's for my monkey. Now, what I like about the image cell or an image built into Xamarin Forms is that when I hit save here, it's going to automatically know how to download those images on demand and cache them for a specific amount of time. So now I have my monkeys here, all in a list. Everything is really good. Everything is lovely. And I can see exactly where they live. Now, this is just one of the predefined ones. So it's not super looking amazing. So we can fix that. I have a very beautiful cell down over here. So instead of using a built-in one, I have a very pretty cell here. So I'm going to go into this data template again. And I'm just going to copy and paste this in. It's actually really not that complex. I have a frame, which is basically a card view, like a nice little card with a little drop shadow. And it's actually using our visual material design. So this will be exactly the same 100% between iOS and Android. And then I'm going to give it an image inside that frame on the left-hand side, and then location and name, and specify the font sizes and things like that. So now when I hit save, I come over here. Now we get almost beautiful monkeys. They're so close. And that's because we've done one thing not correct so far. And we will let IntelliCode tell me what I've done wrong, which is, I don't know how it knows, but I haven't set has uneven rows. Because by default, iOS and Android specify a very specific height from each item. So what we can say is it has uneven rows. You can specify how high you want it to be, like 100 or 125. But if you say has uneven, it will automatically calculate it for you. So when I say that, now we get beautiful monkeys inside there, and now we can scroll them inside of these beautiful list view with the card views inside there, which is very cool. Now we also have this get closest button, and that's actually in our view model down here. So if I come in here, you can see there's no code in here yet. But if I come in at a breakpoint, I'm debugging my application still, right? Still right here. So what I want to do is I want to use geolocation, and I want to go and find some monkeys. So I say, as long as I'm not busy and as long as I have some monkeys, we can do geolocation. So let me go and continue on. We could come in and start writing code. So I have the permissions for geolocation set up here. I'm going to say location, var location equals. I'm going to say geolocation, which is part of Xamarin Essentials. And I'll say get last known location async. And we're going to put an await in front of there. Now that is one of the APIs that is built in. Now, this will automatically detect on the device if I have a location that's cached. But if I don't have a location yet that's not cached, it's going to be null. And what we want to do at that point is do a real geolocation request. So we'll say location equals await geolocation dot. And what I love here is that IntelliCode actually knows about my custom controls, my custom namespaces, my custom code. Because what I did ahead of time is I ran IntelliCode, because you can run it on your own code and create your own machine learning model. So I actually wrote it on my own code, which is cool. We have a bunch built in, but you can extend it. I love IntelliCode. It's one of my favorite features. And here what I'm going to do is I'm going to give it a geolocation request. So I'll say new geolocation request right there. And this request has a desired accuracy. So we'll say accuracy dot, what does IntelliCode tell me to do? Medium, perfect. And then I'll give it a timeout. And that's a time span dot from seconds, and we'll do 30. And now we're basically ready to go. Now you're probably wondering this entire time, why are all these squiggles here? Well, that is because it's XAML Hot Reload. It's not code reload, because we'd have to recompile your code. We control the UI stack. We don't control your code just yet. So this is literally telling me here, hey, you've made these changes, but we're not going to be able to run them until you recompile your application, because we need to recompile that code. So what we're going to do is stop here, and we're going to stop debugging, and those squiggles will go away, because it knows that I'm going to recompile it. Now I am going to do a few more things. I'm going to copy in a little bit of code here. And once I have the location, we're just going to find the closest monkey to me. All right? So if I come over here, once I have my location, we can actually calculate the distance between the monkey's latitude and longitude and my latitude and longitude using Link and Xamarin Essentials. So this will calculate them, find the first one, which will be the closest to me, and then it will display that in a pop-up. So now I'm just going to hit debug again over here. And what we should be able to do, let's see, lat long for address. Let's see if this works correct. I like this website. Unless anyone knows the lat long off the top of their head? No? Okay. So we're going to go ahead and open our Android emulator here. And you can go ahead and paste in lat and long for the device. We're going to hit send. So now it'll update the currently reported on there. All right. So now our application should reload. I'm going to hit find monkeys. I don't know what's doing there. Let's hit find monkeys. Now we get the full spinner because it's doing that full request. It was cached before, so it was super, super quick. This should go off to the internet, find those monkeys for me. There we go. Beautiful monkeys. Now what we'll do is let's add a little breakpoint here. So we'll add some breakpoints. I'm going to say get closest. We have that code that's in there earlier. We'll continue on right here. I'm going to hit continue. Location doesn't have any yet. So it's going to go off to the internet, not the internet, but the device, grab the location, which it now has. Now it'll be cached. And then it's going to go ahead and find the closest monkey to me, because each monkey has a latitude and longitude. I don't actually know what monkey it'll be, but it is the mandrill, which is in southern, either Cameroon or the Congo or Guinea, wherever that is at. I don't know if there's European monkeys. I hope there are somewhere, and I should add them to my list. But that's the closest one to where we're at based on the list that I have. So immediately, I've started to not only leverage any shared .NET code that I already have, I put it into MVVM. I added a few little nice Xamarin Forms helpers so I can bind them to click handlers. I added my UI in real time against my real data. I didn't have to stop debugging. And then when I want to write more code in my code behind, like Xamarin Essentials, boom, I'm able to do that immediately in just a few lines of code. And this is stuff that you can do today. I added geolocation in 2 lines of code to my application. That's amazing. And that's a type of productivity we want to give you. Not be able to write this code, but be able to share it everywhere. Now, one thing I haven't done yet is that I haven't run this on anything but Android. So what I'm going to do is I'm going to set iOS as my startup project. And what I have over here is my Mac, which has been slowly draining my battery. And I was using it earlier, and it was down to like 20%. Now it's down to 30, or it was at 50% when we started. Now it's at 30%. It's amazing that what just not doing anything will drain. And for iOS development, what we have is the ability to deploy to a Mac machine, because that is where Xcode, the iOS simulators, live. So over SSH, I've paired this to my Mac, and I've logged in. And automatically, we're going to find any device that's plugged into your Mac or any iOS simulator. So over here, I have my iPhone 8. I'm just going to hit debug. This is now going to compile my C# locally on my PC, and then do a final build and compile to deploy it onto an iOS simulator. Now, what's really unique about this part is that we built tooling into Visual Studio on Windows to enable you to debug and see an iOS remoted simulator on your machine. Now, I could have taken this exact same solution and opened it in Visual Studio for Mac. That's what I was going to do, but the internet seemed to work here, so that was really good. And this could be like any Mac. This could be my Mac back home. As long as it has an IP address, you can be good to go. So now I'm debugging my app, and a remoted iOS simulator for Windows pops up. And what this has done is it's talked to our Mac, and it actually started an iOS simulator over here, and it's basically forwarding all the goodness onto my machine, which is really cool. So now, when this boots up, we're going to come in to my iOS application. I'm also going to go into the settings and choose a location. Here you have to pick one of them that's built in, so let's say Apple, which is in California. Here I do have this device in dark mode, so I haven't programmed this app for dark mode, but we'll go ahead and find those monkeys. And this should populate my list of monkeys. There we go. So now we're back in normal mode. And I can actually use my finger to scroll through these monkeys. It'll download this because it's a touch screen, which is cool. It's actually like beneficial, right, in general. And then I can come in. I can hit Get Closest. This is going to go in, do all the things that it did earlier. And it's going to find Henry, which is one of my little stuffed monkeys that I bring around with me, who's located in Phoenix, which is down here, right there. Also, this is the red-shanked Duke Langer. It's the most beautiful monkey on Earth, I think. It's only found in Vietnam or Laos. I just got to go on an eco tour in Vietnam. It's absolutely amazing. That's really what they look like. They're real monkeys, and that's totally what they look like. It's astonishing. So if you ever go to Vietnam, please email me. I'll give you my eco tour guide. It'll be the best thing you've ever done in your entire life. There's only 1,300 of them left in the world. It's very, very sad, and their ecosystem is being actively destroyed. So if you go and support them, that'd be great. I give lots of money to their charity. It's amazing. I love monkeys, if you couldn't tell. So we started with Android. We extended it with Xamarin Essentials. We built cross-platform user interfaces. We built things and reloaded it in real time and added geolocation in just a few lines of code. And that's what we're really enabling you to be more productive to build these beautiful applications. And when I mean beautiful applications, you can really build beautiful applications. I showed you that list of companies building applications with Xamarin every day. But we've been really expanding the Xamarin toolkit really around Xamarin Forms to add more and more controls. So what we did is we did challenges with our community, you, our developers that are using our tools, and challenge them to build beautiful apps. Take existing apps, take apps that you've been thinking about, or designers' applications, and let's build something cool. So we did a challenge to see what you could build in just a few hours. So this is the Coinbase application, which is a cryptocurrency application. That's the real app. And one of our developers in the community, in just a few hours, recreated it in Xamarin Forms for iOS and Android. One of our developers, Ryan Davis, down in Australia, one of our, I call everybody a developer. Like sometimes Microsoft, you'll hear everyone say customer. I don't know, I just feel like I don't sell a product, so everyone's a developer. So one of our community developers, Ryan Davis, he flies Qantas all the time. He recreated that application in Xamarin Forms in an afternoon. One of our amazing community members recreated Netflix in Xamarin Forms. I mean, the types of applications you can build are real applications. And often you can take things that are existing from designers and applications already built and obviously rebuild them, but you may have your own designers that need you to implement them. One of our amazing community members, Steven, who builds awesome libraries, he found this awesome markup design on Dribbble, which is a design website, so he built it in Xamarin Forms. He just built it. He was like, go for it. So you can really, truly build beautiful applications, and at the same time, you can use your favorite integrations and your favorite libraries. Because we don't stop there. We build a lot of things, but there's beautiful, awesome libraries in the .NET ecosystem, iOS, and Android. So that means your applications can use everything we're building and everything that Microsoft, third parties, and the community are building. Whether it's cognitive services to add AI and machine learning, Azure Active Directory, SQLite, Telerik, Syncfusion, barcode scanning, super fast data caching, or animation libraries like Lottie, these are just some of the most popular ones out there. There's even additional third-party frameworks that are really popular with Xamarin, such as Uno, MVVM Cross, Prism, reactive extensions, and a lot more. And since Xamarin has been tried and true for over a decade, we have tons of integrations into the entire ecosystem from start to finish. So not only can you build your application, but you can continuously integrate and deliver it with world-class tools like Azure DevOps, Bitrise, App Center, Fastlane, Jenkins, anything. Just because it's a Microsoft product doesn't mean you can only use Microsoft technology. It's a mobile app, you can use what you want, which means you can integrate with any cloud backend that you want either. We, of course, have amazing Azure integrations, as you would assume, but if you want to use Google Cloud Platform, AWS, or Firebase, we have those libraries available. Some of them we bind like Firebase, but AWS and Google also provide some for Xamarin developers too. But from start to finish, you have everything that you need to build beautiful native applications, or truly as a .NET developer, any application that you want. You can get started, just go to xamarin.com, install Visual Studio, it's free, you can do all the things. That's my time. I went way over time, but thanks. Yeah.
Thank you.